we've talked about similar triangles quite a bit already. There are some properties of right triangles, similar right triangles that are unique, that are extremely useful. Okay, so let's take an example of something like this. Say we've got a big triangle, ABC, that's a right triangle. Okay, notice we have a right angle in that. And just to kind of get ourselves oriented so we can see this more easily, let's orient this a specific way. Let's put the hypotenuse down horizontally, sitting on the coffee table. And look what happens here. If we drop an altitude, we say in geometry, or a segment down from point C to the hypotenuse of that big triangle, so that it hits the hypotenuse at a right angle, perpendicular to the hypotenuse. I want you to notice what happens here when we do that. Now let's take an example, that just for the sake of argument, to make this easy to deal with. Let's assume, and we don't have to do this by any means, but I think it's helpful. Let's assume that original triangle was a 30, 60, 90. Okay, let me make sure all phones and everything please should be completely away. If you follow that, I can promise you this, if you follow this closely, today you're going to be fine in chapter 9. If you don't, honestly, there's not very much time left and you might struggle a little bit. But if you really follow this, you'll have it. This is a useful relationship that applies all through chapter 9. And once you get it, you got it. It's easy. So if this is a 30, 60, 90, there's the 90, right? So that would be the 60. And it has to be, if that's 90, then these two have to always add up to 180. To 90, right? Because all the angles in the triangle add up to 180. So if one of them is 90, the other two must also be 90 combined. So we're looking at the big one. So ignore that little, right? So it's the outside one. Okay. Now let's look at the other two triangles we created by dropping down that segment, that altitude. Let's look at the medium one. That's a right angle, isn't it? Right? So if that's a 90 and that's a 30, what's the measure of this angle up here? 60. Ah. Right? Now let's look at the little guy. That's a right angle. That's a 60. So what's this one up here? 30. Well, look at that. They're all 30, 60, 90 triangles. So all three of those are similar to each other. How about that? They're just scale versions of each other, right? That is extremely useful. Okay, what if we've got a situation like this, let's say, where we want to calculate. We can't measure it directly very easily, but let's say we want to calculate the height of this roof. We're doing a building project over the summer. Now, we could pretty easily just hang a tape measure over the lip right there and measure that to be 5.5 meters. We could do the same thing right here, measure that to be 3.1 meters. And we could measure across the house pretty easily too. But it's difficult maybe to get that measurement directly. Now we can use geometry though and set this up pretty easily. Let's take these three right triangles that are created here. We've got the big outer right triangle. And notice that what makes this possible is that's a right angle up there, right? So if we cut this thing down vertically, we're going to get a medium, a small, and a big right triangle. Now look what happens if I take all three of those triangles. Here's what I'm going to do in the next slide. I'm going to take all three of those and separate them. Then I'm going to twist them around so they're oriented the same. So it's easy to line up the corresponding parts. Okay? So there's the little guy that we took off of the left edge. There's the medium guy that formed the right edge, right? Kind of the right piece of the roof. There was the left portion of the roof line, and there's the whole thing in cross section. Big, medium, little. And line them all up. Now, if I want to solve for h, well, all I've got to do is come up with a ratio, similarity ratio. This is how we would have done this. We could have done this problem quite a while ago, in chapter 8, right? Easily we could have done this problem. There's an h. Do you see a ratio I could use to solve for h? Corresponding parts? Say that again. Listen. Okay, so we'll use the small triangle and the large triangle. So small hypotenuse to large hypotenuse equals small vertical leg divided by large vertical leg. Right? And then how would I solve for h? Cross multiply and isolate h. Yes, ma'am.
How come you're not doing big to small this time?
Doesn't you mean how come I didn't do?
Like 6.3 or...
Oh, you know what? Doesn't make any difference. All that matters is that I'm consistent. I have to do the same thing both times. Okay? I could have done that. It would have worked. And so then I would just cross multiply and get 6.3h equals whatever 3.1 times 5.5 is, divide by 6.3 and throw it on my calculator and get an answer. Right? And if we do all that stuff, what do we find? There was our ratio, right? So divide by 6.3, we get about 2.7. About 2.7 meters is that height. Okay, so we're able to calculate that instead of having to measure it directly. Okay. Well, in general, there's an easier way to do this stuff. We don't have to actually set up all those triangles like that. We're going to be able to set up some general ratios that are always useful to us. Now, here's how we can do this. Let's take the same situation as before. Let's take this big triangle, and it's kind of scaled down there. There's the big triangle, A, B, C. And let's break it into the big, the medium, and the small versions. Okay, so there's the whole thing. There's A, B, C. There's A, D, C. And there's the little guy, C, D, B. And they're all lined up so we can see the corresponding parts. Okay, now do you see any shared sides among those three triangles down here that we've separated? See any sides that are the same in all of them? It's an example of a side that shows up in two of the three triangles. CD, okay. Yeah, CD is one. Let's look at that. So here's CD, and here is CD. Now what we're going to do is we're going to break up all these right triangles. We're going to break them up into the hypotenuse, the short leg, and the long leg. And we'll just label those H, S, and L. Okay, I want you to see a pattern here. And by the way, when you're doing these kinds of pictures, when you're drawing your own triangles, it's helpful to exaggerate the triangles. So you can see that in the triangles, we've got one leg that is clearly shorter than the other. Then it's easier to keep everything straight. Even if they're not in real life, it doesn't matter. You can distort your pictures in geometry. It's fine. All we care about are the numbers anyway. So use that principle of exaggeration. Make it easy to orient those two sides. Now, if we look at, in terms of those three possible sides of a right triangle, the side CD for the small triangle is what side? H, the hypotenuse, L, the long leg, or S, the short leg? It's L, isn't it? Yeah, that's L. Okay. What is it for the medium triangle? Yeah, it's the short leg, S. Okay, so now here's the trick. If the shared leg, or the shared side, plays the role of the long leg in one triangle and the short leg in the other triangle, then what we're able to do is set up the ratio. All we're doing is saying the short leg over the long leg, or vice versa, it doesn't matter, for the small triangle equals the short leg over the long leg for the medium triangle. You know, what do we get when we do that? For the small triangle, what is the ratio of sides, short leg to long leg? What's the short leg of the small triangle? Side DB or BD, whatever you want to call it. Okay, what's the long leg? CD. What's the short leg of the medium triangle? CD. Uh-huh. Oops. And what is the long leg? AD. Okay, now notice something that happened here. The shared sides always line up diagonally, so they act like a geometric mean. Okay, that's going to happen every time we have a shared leg and we set up a ratio like this. Okay, so the result is then, they summarize it for us here. There it is, right? That's what we just found out. Okay. How is this important to us? How can we use this? Let's take an example of a problem that uses this. Right there. Okay, let's take this one, this upper left one, how about? This guy, we want to solve for x. We grab that and let's give ourselves a little more room to work. Okay, I want to solve for x. Now look what we're given here. We're given 3 lengths, x, 6, and 3. If we can find one of those 3 sides that's shared by 2 triangles, we can set up one of those, a ratio like we just did. Okay, now what's the shared side here? X. It might be helpful, at least at first, to literally separate the 2 triangles. So we've got the medium triangle and small triangle. And this distance is x. Okay, now in the medium triangle, what side does that represent? X there. L, H, or S? S, right? What side does it represent in the other triangle, the small one? L. Okay, so our ratio then has to involve short sides and long sides. Short side over long side for this triangle equals short side over long side for that triangle. Well, if we fill in the blanks, what's the, let's see, 6 goes here, doesn't it? And 3 goes there. So what does this ratio look like? Short over long. That's long, that's short, right? But short over long for the medium triangle. Okay. Oops. X divided by 6 equals what? Well, how about over here with short over long? Yeah, 3 over x. Okay, how would I solve that? Cross multiply. Always cross multiply, right? So if we cross multiply, what do we get from that diagonal product? X squared. And then from the other product, 18. How do I solve that? Square root. Yeah, we got it. There's our answer. Put it in the calculator, get a decimal, we're done. Okay? See how that works? Okay? All right, well. Using that same logic, we can set up some other relationships. You told me that CD was a shared side. What's another one?
I have a question about the last one. Is
Sure.
it always going to be S over L?
No, it might not be. It might involve hypotenuses. We'll see some that it's not always those two.
Well,
How do you tell? Well, because the hypotenuse is always opposite the right angle, right? And the short leg, the other two, we can see one shorter than the other. Right? That's why you want to draw the triangle so one leg is definitely shorter than the other. Okay, what about it? What's another shared side in those bottom 3? AC. Okay, so AC works. Yeah, I've got AC shows up right there as what side? Hypotenuse. Okay, so AC is the hypotenuse. And then AC shows up down here as what side? Long leg. Okay, so now we're going to set up a ratio involving long leg and hypotenuse, right? So we should be able to say for this triangle right here, L over H equals, for this triangle down there, L over H, right? So what's L for this one? If I fill in the blanks, that's H. So L would be down there, right? So what's that first ratio look like then? Okay, so AD over AC The long leg of the big triangle is L. Short leg is what? Oops, not short leg, the one hypotenuse, don't we? What's hypotenuse? AB. So there's another one, right? And then the last one I guess we could do is CB, right? If we look at CB, we maybe won't go through the whole thing, but you see the idea here. If we look at CB, there's CB. It's the hypotenuse of the small triangle and the short leg of the big triangle. So I could set up the same kind of ratio there, couldn't I? Right? Okay, let's try those now. Let's try a couple problems using this stuff. How about this guy? So we got three things. We got y and 2 and 5. You see any of those three that are shared by two triangles? Y is, isn't it? Y is shared between what two triangles? The small and the large. Yeah. Right. So if I split those out, there's the small, right? And that's y. And there's the large, and that's y. Okay, what side does y represent of the small triangle? Hypotenuse, okay, so we got h. What side does it represent of the big triangle? Short leg. Okay, so then we need to find the short leg of this guy is right here, right? And the hypotenuse of that one is right there. What numbers can I fill in? What goes up there? 2. Okay, good. Now, what's the hypotenuse of the big triangle? 7. We got to add them up. Good. So what's my ratio then? Isn't it just, I'm just getting, like I've got short and hypotenuse, so what's short over hypotenuse in the 2 over y equals y over 7. How do I solve? Yeah, y squared equals 14. Cross multiply. Okay. There it is, y squared equals 14. Okay, so y equals the square root of 14. Good. Okay, what about this one? This is one I like. Say that, here's the situation for this one. Some eccentric billionaire just told you that he's challenging your intellect. If you can, in 5 minutes, if you can estimate to within 6 inches the height of this track, he's going to give you $1 million. Okay, how are you going to do that? Can't measure it directly.
Shadow.
You might be able to do something like that. Yeah. 5 minutes can make that tough. You might be able to do something like that, though. There's some things you could do. Now, how about this? If you have something with a square edge on it, envelope, iPod, whatever, if you line that thing up and put it up to your eye, and then you just walk backward and forward until you can sight along one edge of that to the top of the track, and along the other perpendicular edge to the spot on the ground right below the track. Okay? If you can do that, and maybe we have, I don't know, maybe we have something like we have a little meter stick, or even if we don't, we could probably estimate these distances okay, just by, there's 1 foot, 2 foot, 3 foot, etc. We could find out if we walked horizontally from right there, oops, if we walk horizontally from there over to there, we find that distance is 16 feet, roughly. Okay? How high are our eyes above the ground? We can estimate that. Say it's 5.75 feet. 5 feet, 8 inches about 4 inches, say you're 6 feet tall. Okay? So if we've got those numbers, that ought to be enough, right? Because the important thing here is that this is a right angle, right? So I should be able to, on a piece of paper, I should be able to split this up into right triangles and use those ratios we talked about. Okay, now let's take this picture and do something with it. See if you can win the $1 million. If you do, just remember who taught you all this stuff, please.
Does that make you feel better? Good.
Okay, so let's fill in the stuff that we know here. It looks like we've got a 16. We know this distance right here is 5.75, and what we're trying to find is that overall height. So what could we do? Do you see any ratios where we got some shared sides? Say it again. Oh, share the 16. Yeah, that's good. Yes, ma'am.
Could you just add the 575, 575?
To the which one?
Like on the right side, it says height is like 575, 575.
Oh, that says height. The height is the whole thing, which is unknown, and that says h minus 5.75. Let me get rid of that stuff. That's probably confusing. Let me just get rid of all that. There. We don't need that stuff anyway. We don't need any of that now. Okay, we got everything we need. Okay, so we know this is 16. That's the shared side. So if I split out those two triangles, what do I get? Here's the medium one. Right? And here's the small one. And I know this is 16. That's 16. Now there's the shared side. What does it represent? What part of the small triangle is it? Long. Okay. What part is it of the medium? Short. Okay. So I need the ratio of long and short. Okay, well the short side here I know. The short side is 5.75. What's the long side up here? I don't know. Call it x, right? Okay, because if I knew x, I'd have the answer, wouldn't I? Right? I could just add x and 5.75. Time's wasted. We got to hurry. We're not going to get our $1 million. What do we do to solve this? What's our ratio? Okay, 16 over x. Okay, so we're doing short to long. That's fine. Short over long equals 16 over x in one triangle. What does it equal in the other one? Oh man, we're going to make it. Okay, now you have a calculator on your cell phone, so that'll work. So if we cross multiply, we get 5.75x. You borrow one from somebody. Tell them you'll pay them $100 to use your cell phone for.
But I'm poor. I can't.
You're gonna have $1 million.
Well, you're about to win $1 million. 16 times 16, 256. So what's x?
Yeah, it's 256. You left like 5.75.
Man, I'm getting nervous. We can get it.
Nope, 5 minutes.
What do we find? What do we get? 256 over 5.75.
No, we don't win $1 million.
44.7.
What is it again? 44.52. So about 44.5 feet. Okay. All right, we just made it. $1 million. How about that? Oh, you're right. Hang on. 4.52 plus 5.75. What is it? Quick. Yeah. 50.27. So about 50 and a quarter, we'll say.
What's our correct answer?
That's it. 50.27. We did it right. Okay. Sound good? Just like that. Just, you know, who says math can't be useful? $1 million we just won.
Yeah, but what are the odds of that scenario?
Oh, well, I don't know. We don't need to worry about odds. It could happen. Couldn't happen.
Let's calculate the odds then.
Yeah.
Oh, okay. Well. Okay, try this. If you really got this stuff. Solve for x, please. Get out a piece of paper. Here's paper if you need some. Get your notebooks, that's great. If not, grab some paper.
I was grabbing regular paper out.
Can I use your pen? I'll bring it back
Yeah,
up.
go ahead. What's the shared side? 20. Okay. So if we break this up into two triangles, and I'm not going to write it, I'm just going to color code it. Okay, now listen please. In the shared side is 20. In the green triangle, what does that represent? Short. What does it represent in the red triangle? So there's your ratio, short and long. Okay, so green short over long has to equal red short over long. What's the green short over long? 20 over x equals. Now you can kind of check this to make sure because the same number has to line up diagonally, right? Always does. So then how do I solve this? 12x equals 400, so x equals. Yeah. How about that? No big deal. It's getting too easy. I gotta challenge you. That's, oh, go back.
Yeah, go back.
Oh yeah.
I can't tell.
20 times 20 is 400.
Okay, try this one. I want you to find all three of those. X, Y, and Z. One at a time, obviously.
Oh, we gotta find X and Y.
X, Y, and Z. Now, before you start on this, though, real quick. Now, remember what you have to be able to do. I have to be able to set up a ratio that involves two numbers and one unknown, right? Every time, that's always been the way it's worked. So I have to be able to use the numbers 16 and 14 with one of those variables in order for this to work. Okay. Now, it doesn't have to be, though, it doesn't have to be the variable that's the shared side. In that last example, it wasn't, right? It was one of the other sides that was shared. Okay? Anybody see a shared side there? Now 16 is not, because the hypotenuse of the big triangle can only be in the big triangle, but 14 is shared. 14 is shared by what two triangles? Big and the medium. Aha. Okay. Try that. Right. 14 is the hypotenuse of the medium triangle and the long leg of the big triangle. Right?
You stay there.
Okay, so what two sides did that ratio involve? So it was hypotenuse and long side. Okay, so I got to know both of those, right? In this triangle, what's the long side? X. Yeah. Okay, what about in the great big triangle? We got the long side. What's the hypotenuse? 16. So what's my ratio then? Okay, I'm hearing it.
14 over 16 equals X.
Okay. Good. So everybody see this? Long to hypotenuse, x to 14 equals long 14 to hypotenuse. Got it. Now it's piece of cake. Cross multiply and divide and you got it. 12.25. $14 squared, 196. Okay. So now, if we know x, what's z? If we fill these in. 12.25. The whole thing's 16. Bigot. 3.75. Okay. Now, how could we find y? We have a bunch of ways we could do it here, really. All I need, that's a right triangle, right? And I have two sides of that triangle. So what's one way I can do it without even having to mess with chapter 9 stuff? Hypotenuse is 14, leg is 12.25. It's a right triangle. How can I find what? Pythagorean theorem. Sure, I could use Pythagorean theorem. That'd work. I could also use a shared side there. Y is a shared side, isn't it? Of the medium and the small. Everybody see that? That's easier, actually, I think, than Pythagorean theorem. It's up to you. I don't care which way you do it. Whichever way works best for you. Okay, but does everybody see then if I use y as the shared side, y over x would have to equal what? So y over 12.25 short over long equals what? In this triangle, short over long.
3.75.
Right? Cross multiply, y squared equals some number, square root, we got it. Make sense? How about that?
How about?
Okay.